Number 29. To what temperature must a sample of nitrogen, oh my gosh, 27, you know what, I can do that in my head. 300 K. And 0.625 atmospheres be taken so that its pressure becomes, so this will be P2, makes this P1, at constant volume. Okay, that's the green light to use Gay-Lussac's law. To what temperature must a sample be taken? So I guess this would be T2, right? If the sample was at T1. So we got T1, T2, P1, P2. Okay. So we are solving for T2. Solving for T2. Okay, let's do this. This is probably going to be nice and annoying because we're going to have to take a value in the denominator out of the denominator. That's always super annoying. But here we go. P1 over T1 is equal to P2 over T2. I'm solving for T2. So multiply both sides by T2. That cancels right there. So I end up with T2, P1, T1 is equal to P2. Well, I need to get that T2 by itself. So I'm going to have to multiply it by a fraction where T1 is on the top, P1 is on the bottom. That way those cancel, and then do the exact same thing on both sides of the equation. So when I clean this up, which it really needs to be cleaned up, I have an equation that looks like that. So now we're good to plug and chug. So P2, 1.125 atmospheres. T1, 300K. Divided by P1, which was 0.625 atmospheres. The answer will be in terms of K. Let's do some plug and chug. 1.125, it's 4 sig figs times 3 divided by 0.65, that's 3, so I think we're going to end up going with 3. Let's see, is that right? We're going to go with 3. Yeah, because that's 3, and that's 3, so yeah, we're going to go with 3. So that only has 2, so I'm going to add another 0. I'm going to leave that decimal, let's see. Yeah, I'm going to leave that decimal there. I don't need to move it for any reason. That doesn't seem right. What did I do? Oh. Look, I only multiplied by 3K. Yeah, that's why that doesn't make sense. Let's try this again. Good thing I had a ballpark idea of what this should look like. Clear. 1.125 times 300K divided by 0.625. Okay, that makes a whole lot more sense. 540K. Now, 3 significant figures. In order to make sure that 0 is significant, I simply place a decimal. Now, if you wanted to report this in degrees Celsius, which you totally could, it'd be 267 degrees Celsius.